Hello everyone, good afternoon. Welcome dear authors and invited guests. Welcome to technical session 11A. Myself Karthik Bharadwaj and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Solistic LLP, it's my great pleasure to welcome you to the Third World Conference on Information Systems for Business Management ISBM 2024, Bangkok, Thailand. The third edition of the conference is being organized in a hybrid mode. The physical event is organized today in Bangkok, Thailand, and the virtual event is being held through Zoom yesterday and tomorrow, that is 12th and 13th September 2024. I hope you will find this session knowledgeable and interactive throughout the day. In this session, we have 6 presentations. Each presenter will be given 12 minutes for presentation and 3 minutes for question answer round. At 10 minutes, I will raise a gender reminder. If you have any query or any update, you can write it to us in the chat box. And there is a humble request to all the participants to stay connected with us till the closing remark. Just before we get started, I would like to introduce you with today's session chair, Dr. Jitendra Bhatia. Professor Jitendra Bhatia is currently an associate professor at Nirma University, Ahmedabad, India. He has more than 16 years of teaching experience at undergraduate and postgraduate level. He has published, presented a number of papers at reputed international and national level journal and conferences. His main research interests include protocol design for intelligent transportation system, software-defined network, vehicular networks, and cloud computing. I request sir to kindly address our participants. So we are moving towards the first presentation of the day. For the first presentation, I would like to call Govardhan Sharma for the paper title, A Personalized Culinary Experience Through the Collaborative Filtering Algorithm and Ingredient Customization. Presenter, you may proceed with your presentation. I think so he may be facing some network issues. So we are moving towards the next presentation. For the next presentation, I would like to call Subha for the paper title, Aspects-Based Sentiment Analysis of Nepali Text Using Bird-Based Model. I request the presenter to kindly proceed with their presentation.
Hello, sir. Am I audible?
Yes, ma'am. You're audible to us.
Yes.
And kindly proceed with your presentation.
Is the screen visible, sir?
No, ma'am. Yes, ma'am. Now it is visible.
Okay, just a minute. So shall I start, sir? Hello?
Yes, ma'am. You can proceed.
Yes, please start.
Okay. Good afternoon, everyone. It's me, Suprabha Regmi. I'm a graduate from Institute of Engineering, Punjab campus, Lalitpur, Nepal. And I am here today to give my presentation on my research topic, aspect-based sentiment analysis of Nepali text using bot-based model. So these are the outline that I will be discussing today. So let us start from the introduction. Others' opinion have always mattered for we humans. And social media these days are flooded with lots of opinions and feedbacks on various subjects. Consolidation of opinions on various such platforms urges the necessity for a new field of study, that is sentiment analysis. Evaluation of opinion in text to find writer's mental outlook is what sentiment analysis is. Author Liu et al. In his book Sentiment Analysis and Opinion Mining mentioned that sentiment analysis is classified into 3 levels, namely document level, sentence level, and aspect level sentiment analysis. This aspect level, also called as aspect-based sentiment analysis, is a fine-grained sentiment analysis in which various subtasks are performed. The main idea it is based upon is that the review text consists of an opinion term and a target on which the opinion is targeted to. So the main work here in aspect-based sentiment analysis is to find the opinion term, opinion target term, categorize the opinion term, which we call as aspect category, and find the polarity for it. Let us understand aspect-based sentiment analysis from an example here. The English translation for this sentence, which is shown in left side, which is in Nepali language, is English translation is, why is Nepal declining? Where have the politicians lapsed? There are 2 target terms in this sentence that are Nepal and politician. and their corresponding opinion term are declining and lapsed. Here, two aspect categories, general in both the case, and two aspect category polarity, negative both the case. Now let's talk about the research gap. There are very few papers on aspect-based sentiment analysis in Nepali till the date, although we can find papers on aspect-based sentiment analysis in other South Asian languages. Previously, author Oisman Singh and his team prepared the dataset for Nepali and experimented for aspect term extraction task and polarity classification task, but there was area of improvement is explored on literatures on aspect-based sentiment analysis. So this current research focuses on data extension and enhancing the performance of classification task and addressing the target-oriented opinion term or opinion word extraction on Nepali language text. So the main objective of this research is to identify opinion term, target term towards which the opinion is targeted to, aspect category, aspect category polarity of Nepali dataset. So these are some of the points I have pinpointed from the literatures I have gone through.
Ma'am,
Sorry?
your title slide is only visible to us. Kindly change
Okay.
it.
Is it visible, sir?
Ma'am, we are only able to see the title slide of a presentation.
Only title. Okay,
Yes, ma'am. The rest is not visible to us. Only the title, first page.
okay, give me a second, okay? Is it visible now, sir?
Yes, ma'am. Now it is visible.
Okay. I was talking about literature review, okay? These are some of the points I have pinpointed from literatures that I have gone through. Actually, the study of sentiment analysis started from 2004 AD. And today we can see several research papers on sentiment analysis and aspect-based sentiment analysis, not only in English, but in various South Asian languages like Hindi, Indonesian language, Urdu, Bangla, and Arabic as well. Previously, rule-based and machine learning methods were focused, which focuses on handcrafted features like lexicon in order to train scientific classifiers. But nowadays, most of the papers mention the use of deep learning techniques on aspect-based sentiment analysis task because of its several benefits over machine learning techniques. So, while talking about the Nepali, Oisman Singh and his team introduced benchmark dataset for Nepali aspect-based sentiment analysis named as NEPSA, that is Nepali Sentiment Analysis Dataset, and evaluate by using various machine learning models. Now let's move towards the methodology section. Before describing the flow of this diagram, I like to define the task at first. If S is a sentence that consists of several words, then the task here would be to detect following things like opinion term, where opinion term belongs to the sentence itself. Next is target term, where target term also belongs to the sentence itself. Next is the pair of opinion and target term. Next is aspect category, where aspect category falls is any one element from the set of these four elements: general, feedback, profanity, and violence. And the final task would be to find the polarity of aspect category, where the polarity would be either 0 or 1. Now let's describe this diagram. Here, initially, Nepali dataset is taken and several data pre-processing techniques like concatenation, tokenization are performed. Then after that, information extraction task is performed. On the information extraction task, target term extraction, also called as opinion target extraction, opinion term extraction, and target opinion pair extraction, or we can also call it as target oriented opinion word extraction is done. Target term extraction and opinion term extraction is done using Nepali bot model prepared by Rajan Ghimiri. For target term extraction task, named entity recognition technique is used. And for target-oriented opinion word extraction task, after target term and opinion term extraction, the target term nearest to the opinion term are the targets towards which the opinion is opinionated to. So here, position matrix is taken into account. Then after the information extraction task, classification task is performed. Under the classification task, there are two classification tasks are done. The first is aspect category detection. The next is aspect category polarity detection. Aspect category detection is treated as multi-class classification task, whereas aspect category polarity detection is treated as binary classification task. Let's describe the classification task from this diagram. Here also, initially Nepali data set is taken, then some sort of data pre-processing is done. Then several models are trained for this aspect category detection and aspect category polarity detection task. Here, I have trained SBM, LSTM, BiLSTM, CNN, and bot model for this. Then finally, model is evaluated and some sort of hyperparameter tuning is done. So now let's describe the dataset used now. I have tabulated the details regarding the dataset here. To summarize, we have added 1031 comments and needed annotations on baseline dataset, that is a NEPSA dataset by the author Oispan Singh and his team. And there are 4 aspect categories, namely feedback, general, profanity, and violence. Likewise, 4 target categories: personal, organization, location, and miscellaneous. Maximum word in a sentence is 93, and average word in a sentence is 17. This is the sample dataset. The text is written in Nepali. Sorry, I couldn't translate each of the text in English. This is also a sample dataset for the information extraction task. The dataset is modified in this format, and biotagging schema is used for this. So now let's discuss the results now. This is the result for information extraction task. The first one is for target term extraction task. Second is for opinion term extraction task. And the last one is for target and opinion pair extraction task. The text is in Nepali. And Rogal score has been used as an evaluation matrix for the information extraction task. And from this slide, we can clearly see that the Rogal score for target term extraction task is higher than that of other two. This is due to the fact that target terms are more straightforward nouns and noun phrases as compared to the opinion terms, which are more subjective in nature and context dependent. So this is the performance comparison for target term extraction identification, target term identification task. I have compared my model with that of the authors, and the previous author has used BiLSTM and CRF model, whereas Nepali bot is used here. And it's seen very clearly that Nepali bot has performed very well as compared to that of BiLSTM plus CRF model. This is the sample outcome. And this is the result for aspect category detection task. As already told that several models are trained for this task, and the best one seen with bot model. And for concatenated case, concatenated means text plus opinion term is pair is embedding. And this is the result for aspect category detection task. This is the confusion matrix. This is the confusion matrix as well. And this is the result for aspect category polarity detection task. Here also, best was seen with bot model for concatenated case. And this is the confusion matrix for aspect category polarity detection task. This is the confusion matrix as well. And this is the comparison of aspect category polarity task with that of previous author. And bot plus LSTM and BiLSTM. These are models used by previous author, and we have used bot model, and we can see clearly that bot model has performed better as compared to the previous model. So to conclude, in this study, we aimed to explore the target-oriented opinion word extraction task within Nepali language datasets, which hadn't been previously investigated. Our method outperformed current state of the art for classification task, achieving 82.78% for aspect category detection and 83.13% for aspect category polarity detection task. Despite these promising results, further fine-tuning on domain-specific data is essential for improving performance in different sectors. In future, we plan to expand the data set and annotate additional domains like a telecom domain. Ultimately, this study marks a significant step towards advancing aspect-based sentiment analysis in Nepali, and it opens the door to further research. Thank you very much.
Okay, so one question I would like to ask you that what is the size of your data set?
The size of my data set is, sir, 5,066 sentence.
Okay, so and also you have mentioned in your conclusion that your future plan is for expansion. So how will you expand your data set?
Sir, I have currently used the dataset from YouTube comments and from news and politics category news and politics category videos I have taken, and those comments I have taken is my dataset. And in future also, I will expand my dataset from that source, sir.
So are you thinking from multi-model also, means from data from different platforms also?
Till now, I haven't thought about that, sir. But in future, yeah, that might be the good idea, sir.
Okay, fine from my side. Thank you.
Thank you very much, sir.
Thank you, sir. Thank you, Super Ma'am. Now we
Thank
are
you.
moving towards the next presentation. For the next presentation, I would like to call the guest for the paper title Deepfake Audio Detection Using Shallow Convolutional Neural Network. I request the presenter to kindly proceed with their presentation.
Yes, sir. Good afternoon, everyone.
Yeah, please.
Yes, sir, you can proceed with your presentation.
Yes, sir. So, my title of project is Audio Defect Detection Using Shallow Convolutional Neural Network. And this is me, Durgesh Badole, and my team, and along with my 3 team members, we are from the same college and same department. And talking about the deepfake audio detection, many of person thinks that the deepfake is generally made of a video or images something, but that's not true. Today in this world, deepfake audio detection technology has been coming across various pathways to tackle such a solutions. But nowadays, during what happens, the models or training models are exponentially growing that such a that a person is unable to filter out that this audio is synthetically, which means AI generated, or it is a real one. A person can never find it out. Hence, we have made a model which can efficiently predict that a model audio is synthetically generated, or it is AI generated.
Mr. Durgesh, I think you can skip this basic introduction. So you can focus on your literature review or might be your core work, right?
Yes, sir.
This can be skipped for basic introduction. So
Okay.
already most of people will aware. Yeah.
Okay.
Yes, one we can start.
So what we did in this project, so we have gathered some of the audio files from 2018 dataset from Mark Henry, which contains 31,565 audio samples. From that audio samples, we have developed an CNN architecture, which consists of 4 convolutional layers, which basically responsible for feature extraction, and 4 max pooling layers, which reduces the spatial dimensions, which helps us to focus on the most precious and most effective features. And we have used the one flattening layer, which prepares the fully connectedness layers, and 2 fully connected layers, which process the flattened features and output the final predicted results. So this is the flow way of our project. So first of all, we have the audio file. With the help of Python and its TensorFlow packages, along with the Torch and Flask, we have converted the audio into a waveform. A waveform is basically
सर अभी कुछ है ऐसा सब है मेरे पास.
Durgesh, you may please continue.
Yeah, okay, sir. So with the help of these packages, we have converted the audio into a waveform. A waveform is the image representation of that audio. We have used the CNN model, as CNN has ability to detect various features and important relevant information from the images, so that more accuracy can be achieved with our model. So the waveform is then converted into a spectrogram, which is a time versus frequency domain, in which the features are shown in X in frequency versus time domain. The images are labeled here. So with the help of a TensorFlow, we are feeding these images to our CNN model, and CNN model finally predicts us the result, which is the audio is real or fake. So here you can see that. These are the some of the features that CNN a spectrogram captures during a time and frequency domain. These minute features contribute to the performance of the model. So if uh, any audio is heard by someone, it is nearly impossible to predict it. So that's why with the help of these images, the model can conclude better it is a fake or real. So it is a spectrogram. So talking about our CNN model, which consists of four convolutional layers, which are responsible of extracting the features. And we have used the 2D convolutional layers for the images. Along with that, we have used the four max pooling layers for reducing the spatial dimensions, for focusing on most relevant features, and one flattening layers, which prepares the data for fully connectedness layers, and two fully connected layers, which process the flattening layers and output the final prediction of our model. And we have used the activation function as ReLU and Adam optimization for minimizing the loss function and evaluated the performance of the model. So this is the architecture of our model. So first of all, the input audio is fed, and then the convolutional operation is performed, and then with the help of pooling layers, the complexity of model is reduced, and here the feature extraction process is done at this part. And after that, on the network, which is which last layers of comprises of a fully connectedness layers, which classifies the data and finally predicts our output, whether it is a whether it is a real audio or it is a false audio synthetically generated. So this is our system flow diagram for the whole project. So audio data is fed and audio data is processed. In this, the spectrogram and male frequency substral coefficient MFCC and LFCC are generated, and then the data augmentation process is done. Then after that, the training data is fed on the CNN model. The model evaluation is done. And after that, the input data is processed. So after that, the relevant features of them, relevant images converted from that audio, like MFCC and LFCC, are fed on the network, which on further processing predicts us details. So talking about what is the difference in our model. So first of all, we have come with innovative approach that most of people done work in LFCC and MFCC, but we have used the LFCC and MFCC both to feed our network to minimize the error, and we have improved our model to uh, minimize the background noises for creating any confusions. So our so even after this, the some of the enhancement can be worked with our model, such as the model enhancement can be done with the transformer-based model, which improves the contextual understanding of the audio, which reduces the error in the analyzing phase. And after that, the data expansion can be a significant improvement. We have used till now we have used 31,665 audio samples, but even after the audio samples is increased, the model will it
तो
is
सर
possible to improve the
एक रिव्यू
performance on
वो भी है अपना
various domains.
तो चलो माइनर आपका तो
So
रिव्यू है तो निकल जाएगा रिव्यू है एमटेक
and
का
the
क्यों
third and the last one, which last perform last one we can do is real time detection. We can do this real-time analysis on live detected deepfakes. So these are the some of the main components that can one develop in the future to improve the performance. So that's it, sir. About and we are open, and I am open to questions, sir.
Fine. So Is it your preliminary work, research work?
Yes, sir.
Okay, then it's fine. So, okay, going in the right direction. So, rest. Okay, which activation function you are using? ReLU.
Yes, sir. Really.
Okay. Okay, fine. Thank
Yeah. Thank you, sir.
you. I think yeah.
Thank you, sir. Thanks, sir. There is an announcement for Miss Ayesha. Ma'am, your technical session is 11B. Your presentation is scheduled in virtual room 11B. Kindly join virtual room 11B. Thank you.
Sir, D or B?
B, 11B. The
B.
meeting link has been shared to you in the chat
Okay.
box.
Okay.
Thank you, ma'am.
Mr. Karthik, how many are there?
Sir, we have 5 more.
5 more.
Yes, sir.
Okay.
So for the next presentation, I would like to call Abhay Deshpande for the paper title Design of Low Power Compressor Using Full Adder. I request the presenter to kindly proceed with their presentation.
Hello everyone, I'm audible. Hello everyone, Bhai from this side. I graduated from KLA Technological University. Is my PPT visible?
Yes, sir. It is visible.
Okay. I graduated from KLA Technological University UP. I am here to represent my project on design of low power low power compressors using full adder. The rising demand of low power compressors in the high speed mobile devices like compression, image compression, video compression uses a compressor in the silicon chip, and power dissipation as the limited constraints of handheld devices. Importance of efficient arithmetic device, arithmetic circuits like adder, full adders, and multipliers, VLSI systems in the DSP, and design challenges goals design challenges and goals for ultra low power ladders, and potential benefit of our proposed full ladders designs. And latest survey, we used several studies proposed, and several proposed optimized designs for two compressors focusing on power consumption and improved speed and minimizing area, and innovative gate structures like 3T XOR have explored to enhance the power efficiency. And the main motive of our project is to investigate the trade-off between transistor count, computing accuracy, and power efficiency in the full adder by comparing the traditional simplified and our own novel full adder architectures in the study 6. This study seeks identifying how efficient transistor counts impact both computation and the overall power efficiency in the digital systems. The focus is on analyzing the power efficiency trends of these designs through simulation, evaluating practical impact in the transmission gate logic of full adders. And we use the common architecture for a 4-to-2 compressor, which uses two full adders in the serial manner. And our novel full adder consists of three 2-to-1 muxes and 2 NOT gates. The 2-to-1 muxes are designed using transmission gate logic, which consumes less power than the novel, which is less power than the conventional CMOS design. And here are the results of we used cadence 180 nanometer technology because our college had not as lesser technology. And the main results are the powers. SERF means the sense energible reforce full adders, which uses a 10.15 microwatts, and a conventional CMOS full adder uses 10.73 microwatts, and our proposed full adder uses 3.35 microwatts. So our design is compatible for the main compressor uses in the reducing the partial sums in the multiplication. The conclusion, the versatility of demonstrating by the incorporation of ladders based on the transmission gate logic into 4-to-2 compressors, which exhibits low power consumption and the effective arithmetic calculation processing. These results are confirm that promising opportunities in the low power and low powerful ladder structures implementing modern digital technology. It's important to note that Cadence 180 nanometer technology utilizes in the design and simulation project. For the future, we can use lesser technologies which standard like 10 nanometers and 25 nanometers, like Intel's. And that's my time. Thank you.
So, are you working on any emulators?
No. Not any.
Any emulator you are using? No, no.
No.
Am I audible?
Yeah. You are audible. Hello.
I'm
Yes, sir,
asking
you're
about.
audible.
Are you working on any hardware description language? I'm asking you that.
Yeah. I am working on system Verilog and
Okay, Verilog system.
Okay.
Okay. So this is a part of your any funding project, or is a part of your study or something like that?
No. It's a part of my main projects in the 7th semester we used.
Okay. Good. Okay. Thank you.
Thank you. Is there any other questions?
Thank you, sir.
Okay. Thank you.
Now we are moving towards the next presentation. For the next presentation, I would like to call Zara for the paper title, Inclusive Design, Considerations and Strategies for Digital Service, an Educational Perspective. I request the presenter to kindly proceed with their presentation.
You have my voice?
Yes, ma'am, you're audible to us.
Okay. Hello, I am Zara from the University of Helsinki in Finland. My presentation, the title of my presentation is Inclusive Design Consideration and Strategies for Digital Services from Educational Perspective. This presentation includes three main sections. First, I go through the concept of inclusiveness and its practical manifestation in educational environment. Then I explain integrating inclusiveness principles into the design process of digital services and what are the key considerations and methodologies. Finally, I elaborate on the application of inclusiveness principles and values from educational perspective. Regarding inclusiveness in education, the concept of inclusion was initially rooted in efforts to challenge stereotypes about students with disabilities. Within this, the context of cultural inclusion, all service providers in learning environments are responsible for considering diverse people to promote fairness, equity, and social inclusion. A culturally inclusive environment is defined by respect, effective interpersonal relationship, clear communication, explicit understanding of expectations, and critical self-reflection. When we talk about service design or digital service, public service, private service, or customer service or business service, regardless of the type of services or service providers, the central focus of service design and activities remains the satisfaction of the customer's needs and expectations. The late 20th century was an important area in digitalization, and digital services became an integral aspect of digital service delivery. Later, the concept of intelligence digital service was introduced and defined as services that are fully implemented by technical system when user system based on digital information, computing, communication, and automation technology-based system. With growth of digitalization, digital inclusion became to the discussions. Digital inclusion is defined as utilization of various features of information and communication technology by individuals regardless of their age, gender, ethnicity, physical, or mental abilities. This inclusivity promotes some values like justice, equity, and fairness with society. There are some barriers to cultural inclusion, such as availability, affordability, awareness, and appropriateness. But how we can practically expand cultural inclusion from educational environment to digital services? There are some various educational theories, including constructivism, cognitive load theory, transformative learning theory, and meaningful learning theory. And also educational principles such as concept mapping, Bloom taxonomy, and learning style principles. Here I want to explain how some of these theories and principles support planning and implementing inclusive service goal analysis, inclusive digital content production, and inclusive digital delivery. Here I suggest using educational rules for defining inclusive service goal. Despite of advancement in user experience, knowledge, and practice in digital service design, many services still define goals based on the content rather than users. Inclusive digital service goals suggest that providing opportunity for all individuals to explore their own and others' cultures and background. As a practical approach for planning inclusive digital services, we propose creating objective table outline main and supplementary goals for every user's need and backgrounds that are included. Bloom taxonomy can serve as a guidance framework for digital services providers to define analytical goals based on the user's needs and expectation across cognitive, affective, psychomotor domains. We propose integrating educational science into content, resources, and organization. In educational science, content typically refers to selected portion of knowledge drawn from one or more disciplines tailored to achieve a specific objective. These resources should be selected and prepared accommodate the diverse perspective on value, knowledge, and skills and experiences. To define the content resources, we should have attention to user group, cultural, linguistic, and religious diversity with preference for secularism, ensuring the relevance of the content material to digital lives for fostering a sense of belonging, fairness, and inclusiveness. When we want to select preparing the content and user activities, educational science guide us, for example, in constructivism, emphasize on active learning, considering that tells us that to provide productive opportunities for user engagement. Also, educational science suggests us to consider learning style of the use for the end users. Some users more likely to understand visual material like graphs and pictures. They may like more video. Some other users are comfortable with audio content. They may prefer podcasts, and some other users may like reading text and symbol, and they prefer reading text, and some other may like more interactive content and materials. Then we should have attention that if the content consider the value, interests, and motivation of all users, or we should be sure that flexibility and accessibility of all these activities are considered. About content or organization, in digital content, information architecture and frameworks, wireframes determines the structure of content through each discipline. From educational perspective, content structure may adopt linear or non-linear sequences. In linear sequences, we usually have some criteria, such as description list, problem solution formats, known to unknown, and other hierarchical arrangement. In another structure, I mean non-linear sequences, we usually have alternative pathways, including access to background or advanced content, introduction-centered approach, parallel content presentation, and branching narrative. One principle to make reasonable construction in educational science is often concept mapping. Concept mapping and mind mapping are practical strategies to organizing the content based on relationship between different sections of the content. A very known theory, Gestalt theory, is a very famous psychology theory, offers several principles such as similarity, proximity, common region, figure, ground, closure, focal point, and symmetry that can serve as a guidance for visual content organization. By applying Gestalt principles, designers can create a pleasant user experience and achieve success in their business work. In terms of inclusive digital design, visual classification can reduce the effect of language barrier for low-educated users or immigrants. It assists users whose learning style is more visual than textual. Some other educational theories have proven effective in user interaction and interface design, stemming from human interaction research within digital service design. For example, constructivism and transformative learning theories, which emphasize on active participation and significance of user feedback and interaction, provide valuable guidance to user interaction and user interface designers seeking to ensure equitable accessibility for users. Another significant educational theory is cognitive load theory. It addresses the structured human cognitive architecture and proposes the principles to reduce working memory load. This theory guides how to present visual and textual content without overwhelming users' cognitive resources. It emphasizes the importance of integrating auditory and visual information effectively to minimize cognitive load. In the whole article, I have showed some practical examples that how inclusiveness can be achieved considering educational theories in practice. And at the end, we believe that by applying these theories and principles, designers can create digital services that are more accessible, engaging, and inclusive for all users from diverse backgrounds. The interdisciplinary perspective enhances the quality of the service design and contribute to broader goals of equity, justice, and social inclusion in digital environment. Thank you very much. If you have any question.
Okay, it was subjective, so I don't have any question from my side. Rest, anybody can ask if anybody have any question regarding this. Goals and all these things, please.
I think so. No one is having any questions. So we are moving towards the next presentation.
Yes.
Thank you very much.
Thank you, ma'am. For the next presentation, I would like to call Suhas for the paper title Reinforcement learning for energy efficiency in 5G networks with built-in self-test architecture. I request the presenter to kindly proceed with their presentation.
Yeah, thank you very much. Yeah, is my screen visible?
Yes, sir, your screen is visible to us.
Yeah, hello and good afternoon to everyone. Here, I am presenting the paper on reinforcement learning for energy efficiency in 5G networks with built-in self-test architecture, where the authors are myself, Suhas Shirod, Dr. Ramakrishna, and Dr. Rajshekhar Shettar. The flow goes like this: introduction, motivation, objective, proposed algorithm, results, conclusion, and references. In the introduction, we can see that 5G networks brings the faster speed, lower latency, and better connectivity, but at the cost of higher energy consumption due to increased data traffic and complexity. To address this, we are using a reinforcement learning solution by enabling network to adapt energy use dynamically based on the changing condition. Additionally, built-in self-test architecture, originally used in hardware testing, helps monitor network performance and identify inefficiencies. This paper proposes a framework that combines the reinforced learning with BIST for optimized energy efficiency in 5G networks, aiming to reduce the energy consumption while maintaining or improving the performance and reliability. The motivation behind this is that to address the rising energy consumption caused by the 5G complexity and data demands, RL helps the network adapt energy usage intelligently, while this ensure continuous monitoring for inefficiencies. Together, they optimize energy efficiency, reduce environmental impact, and maintain reliable network performance. The objective of this paper is to develop an innovative solution combining reinforced learning and built-in self-test architecture for optimizing energy efficiency in 5G networks, and to demonstrate that the proposed RL model significantly improves the energy consumption and network adaptability compared to conventional methods, paving the way for practical energy optimized network operations. The proposed algorithm here states that here we have an 5G environment, which is nothing but an open source environment. First, we define the optimization objective for the BIST process. Objectives might include the minimizing power consumption during the testing, maximizing fault coverage, or reducing the test time. Then we will try to identify the network environment. The environment in RL refers to the system within which the agent operates. For BIST, this could be the hardware component of a 5G network system, including processor, memory, and network interfaces that require periodic testing. Then we will try to define the state space. The state space includes all possible states the environment can be in. For BIST, states could be defined by several factors, which may be the current power consumption, test coverage, or detected faults, operational mode, or previous test results. Then we will try to define the action space. The action space include all possible action the RL agent can take for BIST actions mind. This is what is my RL agent here. There we can have the adjusting test frequency, selecting test patterns, power adjustment, test scope adjustment. Then we will try to define the rewards. The reward function evaluates the success of the action taken by the agent. The function should align with our objective. For instance, if reducing power is the goal, the reward could be inversely proportional to the power consumed during the testing. Then we will try to have which algorithm RL algorithm needs to be chosen. Here, the RL algorithm we have used is a Q learning algorithm. The other algorithm than these are the deep Q networks or proximal policy optimization. Then implementing the agent. Implement The agent using the chosen algorithm, the agent learns the best action to take in each state by interacting with the environment and receiving the rewards. Then finally, we will have simulation and training. Simulate the BIST process in a controlled environment to train the RL agent. Use the historical data or synthetic data that mimics real-world scenario to ensure the comprehensible. Then finally, we will have the evaluation and iteration. Evaluate the trained model against key performance indicators related to our objective. Adjust the state space, action space, or reward function based on the performance and retain the model necessary. Then finally, we will have the integration and the real-world testing. Integrate the trained RL agent with the actual BIST process in the testing or the staging environment, then monitor the performance. When we have performed the testing on 8-bit, 16 and 32 BIST with the RL and without RL, we can see the power efficiency and also the power fault detection efficiency. We can see that there is almost the improvement of around 20 to 25% in the power efficiency and 5 to 6% in the fault detection. When we have used the Q-learning algorithm with the BIST, this is what is the result we have got. And we can see the comparison with and without the RL here. Conclusion, the detailed architecture integrates a reinforced learning agent and a BIST module within a 5G network environment to dynamically optimize energy consumption and ensure system reliability through continuous self-testing. At the heart of this architecture, the RL agent makes informed decision to adjust operational parameters guided by feedback from the environment and the result of the BIST modules test. This system represents a sophisticated approach to manage complex 5G network, aiming to balance energy efficiency with high quality communication service. And these are the few references. Thank you.
Thank you, sir. Sir, do you have any questions?
Yeah, am I audible?
Yes, sir.
Yes, sir, you're audible to us.
I'm asking without RL, the results you have shown. So in that you have adopted the traditional ML algorithms.
Yes, sir.
Okay.
So
And
regular
what
RLQ algorithm itself we try to implement,
Yeah.
wherein we try to understand the Q algorithm and try to utilize it with the BIST architecture.
So you have modeled your entire scenario you have framed out for RL, customized environment you have framed out for RL?
Yes, sir. Yes, sir.
Okay. What about tools and technology? You have simulated because this you are working on 5G.
Yes, sir. So we have adopted some open source tools like SRSLT and all. So those tools we have adopted, and also we have done the simulation in the MATLAB.
Okay.
Wherein we'll be getting the simulated environments of the 5G over there for a physical as well as a MAC layer. So wherein we try to simulate it for the PDSH and the PUSH layers, the complete chain.
Okay, fine. Thank you from my side.
Thank you, sir.
Thank you, sir. Thank you, sir. Now moving towards the next presentation. For the next presentation, I would like to call Priyanka Joshi for the take side and the fusion of technology investigating IoT's role in Alzheimer care. I request the presenter to kindly proceed with their presentation.
Thank you, sir. Am I audible?
Yes, ma'am, you're audible to me.
Hello. Sir, is my presentation visible?
Yes, ma'am, your screen is visible to us.
Okay. Good afternoon, everyone. Myself, Priyanka Joshi, and I am here to present a paper on unveiling the fusion of technology, investigating IoT's role in Alzheimer care. First, motivation. Nowadays, IoT devices are available in almost every field. If we talk about household appliances, if we talk about any industry, if we talk about medical, everywhere IoT device, a variety number of IoT devices are available. Along with this, IoT devices are also available for Alzheimer patient. So the main motive behind this survey is to explore and evaluate the role of the IoT for making the life of Alzheimer patient easy, and also making the also reduce the stress from the caregiver of the Alzheimer patient. So the aim is to survey the IoT devices in such a way that one can get the clear picture for which difficulties which IoT devices are used, or which IoT devices helps which kind of Alzheimer patient to which extent. So in this paper, different IoT devices are compared, and a variety of informations of IoT devices are compared in this paper. Now introduction. In introduction, how IoT uh, how IoT become helpful for Alzheimer disease is mainly explained in this portion. Alzheimer disease are rapidly increases nowadays. Alzheimer patient faces so many difficulties like stress, anxiety. They forget their uh, uh, daily activities. They forget some random things. They even forget their relatives, and they due to this all difficulties, they become dependent on their loved ones. Which IoT device help the Alzheimer patient, and how it make them dependent. So before comparing the different IoT devices, let's first understand what Alzheimer is and what IoT is. So first, what is Alzheimer? The Alzheimer is a neurological disorder which wasn't the memory, which affect the memory of an individual. In the initial stage, it affects the memory of the individual in minor level. At early stage, patient forget some random things, but gradually it wasn't the memory of the individual. They do not able to perform their daily task by their own. They do not able to remember their relations. They do not able to remember their family member also. This lead some stress on the family member of the Alzheimer patient, as well as this lead the stress and dependency on the Alzheimer patient as well. Now, nowadays, Alzheimer ratio of Alzheimer patient are increasing very rapidly. This is some figures of the Alzheimer patient. Like in 2000, it's 17.6%, and it increasing rapidly, and it reached up to 37.3% till 2018. Now IoT. So what IoT is? IoT is nothing but it is a network of the interconnected devices. All devices can be embedded with some sensor, some software, and also it can be embedded with some other technology. And these all devices connected together, and they perform some to perform some particular task. IoT devices can range from household appliances to some industry, and also for Alzheimer patient. Now IoT for Alzheimer means how IoT become helpful for Alzheimer patient. So nowadays there are variety number of IoT devices, especially for Alzheimer patient, are developed. For example, some GPS tracking are also available, through which family member can track the place of their patient. Another is automated pill dispenser are available, through which if a patient forget to take pill, then this device remind the patient to take the pill, and once he or she take the pill, they give the notification. uh, then some more IoT devices are available for Alzheimer, like health monitoring system. In health monitoring system, some in health monitoring system, the health of the Alzheimer patient is observed. If BP is if fall down, then directly message sent to the doctor as well as their family member. If Alzheimer patient fall down or become unconscious, then also uh, then also notification is sent to the doctor as well as their family member. And one more IoT device is available for Alzheimer patient, like they daily observe the health of the patient and daily generate the report and send that report to the doctor. These are the few IoT devices which are used for Alzheimer patient, like smart clock, smart watches, automatic pill dispenser, emergency call button, GPS tracking, digital clock. Now literature review. To make this survey, few papers are examined. In some papers there are in some papers, author talk about the latest devices which become useful for the Alzheimer. For example, in one paper, author talk about the speech interaction with the personal robot, and which become helpful for Alzheimer patient as well as the aging people at the home. In this portion, IoT device is collaborate with AI technology. In some other paper, voice based reminders and assistive robots are author talk about the voice based reminders and assistive robots. For comparing the different IoT devices, few survey paper as well as few research papers are examined, which includes IoT technology as well as a few more technologies like AI, ML, and some software like in which Android or iOS technology are used. These are the comparative study. Like in paper number 16, author in paper number 16, the device is which the device is described is a wearable device. It includes the technology. The include technology in that device is IoT and Android app. The sensing devices are used for making that devices are GPS module. It connect with the Wi-Fi. It has some another display unit, buzzer, and there is no additional feature. Another comparison of is in paper number 22. The research device is wearable. It include technology, IoT, cloud, and Android, and it use the sensing a few sensing devices. and it connect with either Wi-Fi or also with the Bluetooth. And for display unit, it uses LCD and buzzer. Then in one more paper, like 25, in 25 paper, the device is both wearable and non-wearable. It includes IoT, cloud, Android app as it technology. There is no sensing devices, and for connectivity, it uses Wi-Fi, Bluetooth, WSN, NFC, and there is no any display unit, and there is no any additional feature. Then another paper, like 27, the device is wearable. IoT technology used in for developing that device are IoT, cloud, and Android. And sensing devices are ADC, MCP 3008, GPS, and connectivity is possible in this devices through Wi-Fi. There is no display unit, and additional feature is this. In this device, apart from the basic feature, it includes the camera, it includes game and quizzes for Alzheimer patient. So this table shows the comparison between the devices in terms of technology included in the developing of the devices and its additional feature. Now another
Priyanka, can you go to
comparison
your now
is
your
for
any hello? Sorry to disturb you, Priyanka. Priyanka, please can you right now focus on the outcome of your work? Now it's fine that you have done enough literature survey
okay.
and you have detailing of wearable devices also.
Sir, actually, this is a survey paper. So mainly,
So any
there is
outcome,
a
that's okay.
comparison.
Any outcome from this that you have got this kind of limitations and what can be the future direction by taking these limitations again ahead?
Okay. Uh,
If
on the
any,
basis of this basis of this comparison, there is some limitation in some devices, like automated pill dispenser. In automated pill dispenser, the device send the notification that patient please take the pill, but there is no any other confirmation that the pill has been taken by the patient or not. So this can be the future research for this particular device.
okay, fine. So that's good. Fine.
Sir, any questions?
No, that's it. Okay, fine. As it is a survey paper, so fine.
Okay, sir. Now we are moving towards the next presentation. For the next presentation, I would like to call S. Rajaprakash for the paper title, The Development of Security Algorithm RB241 using the multi-way path over the distributed ledger infrastructure. I request the presenter to kindly proceed with their presentation. I request the presenter to kindly proceed with their presentation.
Dear presenter, are you there?
Rajaprakash, sir.
Karthik, please go ahead
Are
with
you
the
there?
next session. Next presenter.
Okay, sir. So we are moving towards the closing remark of the session.
Oh, sorry, it's audible. Hello.
So we are moving towards the closing remark of the session. I sincerely thank our authors for their
Karthik,
excellent presentation.
So Raja Prakash is audible now.
Okay, sir.
Raja Prakash is here.
Hello.
Yes, sir, you can
Sir, it's
proceed with
audible?
the presentation.
Yes, sir, you audible. Please go ahead with the presentation. Dear presenter, kindly share your presentation and go ahead with the presentation.
Hello.
Yes, sir, you are audible. Kindly proceed with your presentation.
Sir, I'm not able to listen.
Dear presenter, kindly proceed with your presentation.
Hello, Karthik. Mr.
Yes,
Karthik.
sir.
Actually, I am facing some internet problem because I am on a 12th floor, so I am going back to my cabin. So it will take some 5 to 7 minutes. By
Okay,
that
sir, no
time,
problem.
we can continue, I think.
Yes, sir.
Yeah, please. Yeah, please.
Thanks, sir.
Karthik. Hello.
Yes, sir.
Yes,
Can you please share the screen of my?
Abhay Deshpande.
Yes.
Okay, sir.
Abhay, yes, Abhay, just hold on a second. We will share it after this presentation. And so Raja Prakash is trying to share the presentation right now, right?
Okay.
Yes, sir.
Okay.
Yes, sir.
Raja Prakash, if you are ready with your presentation, please go ahead. Next 30 seconds more. If Raja Prakash will share it, otherwise we'll consider it as a for the publication process.
So we are just moving towards the next presentation. For the next presentation, I would like to call Abhay Deshpande for the paper title, Design of Low Power Compressor Using Full Ladder. Sir, you can proceed with your presentation.
I have done with my presentation, but I just wanted that my screenshot.
You want the copy of the flyer?
Yeah.
Okay, sir.
I have done with the presentation.
Okay, sir. Okay. Thank you.
Karthik, I think Raja Prakash is here and is trying once again. Right. If you can proceed with the presentation, then it's good. But if we cannot, we can consider it for the publication process. That will not affect on the publication, right?
Now we are moving towards the closing remark. I sincerely thank our authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for your support during the third version and on the previous two versions of the conference. We'll be happy to have you in the fourth version in 2025. All the presenters would be getting their digital certificates through email within 2 working days. Further, all the papers have already forwarded to the Springer. The publication will be live within 6 months. Kindly cooperate with the team of ISBM 2024. I also thank our session chair for chairing the session. So, this is the token of appreciation from the team of ISBM 2024 and Global Knowledge Research Foundation and partners. Thank you, sir, for your valuable presence. Now, I request everyone to kindly turn on their cameras for a quick virtual snapshot. I request everyone to kindly turn on their cameras for a quick virtual snapshot of the conference. Thank you, everyone. Stay safe, stay connected.